The next method of factoring that we'll discuss in 5.3 is called the AC method. And it's called the AC method because if you look at a quadratic expression, such as ax squared plus bx plus c, the first step that you do for the AC method is to multiply the coefficients a and c. And so that's why it's called the AC method. So first thing, as always, factor out the greatest common factor if possible. We want to deal with as small numbers as possible. Second step, like I said, is we are going to multiply the a and the c together. This is a modified version of guess and check. It's slightly more streamlined, so it goes a little bit faster than guess and check. Doesn't cause as many errors. For step 3, it's similar to that reverse FOIL where you try to find factors of that AC so that when you add them together, you end up with the middle term B. And this should be an equal sign here. I'm not sure why that's not showing up. So the factors P and Q should end up being A times C. They don't need to be the numbers A and C. But when you add them together, they should end up being that middle term B. So then you split that middle term B, write it as the sum of the factors found in part 3. And then this is where you use the previous method, which is factoring by grouping, because now you'll have 4 pieces. You'll factor by grouping and then check to make sure that your answer is correct. So let's try this out and see how it works. So our first example here, if we have 5x squared plus 3x plus 12. You could try guess and check, and it wouldn't be too horrible because 5 is prime, so you've only got the options of 1 and 5. But you'd have to go through a few options as far as 12 is concerned. So let's try the AC method. AC method says that you've got 5 times 12, which is 60. Then what I do is I make a little chart that says, okay, I need factors that multiply to be 60 and add to be my 32 in the middle. So if you want to, you can just go through 1 and 60, 2 and 30, 3 and 10. You should notice that when I said 2 and 30, that does actually add up to be 32. So that one actually wasn't too bad, but if you can't see it right off the bat, just start with 1 and see what numbers divide into your AC. So in this case, 160, 230, 310, 415, 512. You've got a lot of options. Luckily, it was the second option. So now what we do is we rewrite this as 5x squared. We split that 32 into plus 30x plus 2x plus 12. And it does not matter which order you put them in. You can do 30x plus 2x or 2x plus 30x. It doesn't matter. It'll still work out. Then we do factor by grouping. So we group the first two, we group the second two. If you group the first two, in common they have a 5x, and you are left with x plus 6. For the second two, they have a 2 in common, and you are left with x plus 6. This should end up being the same term. If not, go back and check to make sure that you did everything correctly. So last step of factoring by grouping is x plus 6, taking that common term, and then keeping the remaining pieces, 5x plus 2. So like I said, if you had just gone and tried to do guess and check, you knew that you would need a 5x and an x. It's just the 12 factors. In this case, it ended up being 6 and 2, but you could have tried 3 and 4, 1 and 12 until you got the right answer, and it might have taken a little bit longer. So let's try another example here, and these numbers are a little bit bigger when we multiply them together. In this case, AC is going to be 6 times negative 28. So if you multiply that, you end up with negative 168. So I know that at first this might seem like it's a little bit tricky. We need to multiply to be negative 168, and we need to add to be negative 13. So I guess we need to subtract to be 13. So again, you can go through 1 and 168 is not going to work. So let's try 2 and 84 in this case. That's not going to work. 3 divides in. If you do 3, you get 56. 3 and 56 is not going to give you negative 13. 4 You can be checking these on your calculator. 4 and 42 is not going to give you the negative 13. Again, one of these is going to need to be positive and one's going to need to be negative because we need to multiply to be a negative number. 5 does not divide in. 6 gives us 28, so we're getting close. 7 and 24. That's still not going to work. We're getting close though. So let's try 8. 8 and 21. Ooh, that is going to work out to be negative 13 if we make this an 8 and a negative 21. So that one will work out for us. So now we split this. We say, okay, we got 6x squared, a positive 8x, and a negative 21x. Again, it doesn't matter which order you put those in. And then you still have your minus 28. So again, sometimes you have to go through a few to get there. And that's okay. It's still going to be faster than doing guess and check for the most part. So in this case, you group the first two, 6x squared and 8x have in common a 2x. And you are left with 3x plus 4. And this is where you need to be careful. In the second one, they're both negative. So we're going to factor out a negative 7 in this case. And we're going to be left with 3x plus 4 because we factored out the negative from both of them. They both end up being positive in the parentheses here. And that's good because we end up with 3x plus 4 as our common term. And 2x minus 7 are our remaining pieces. And again, you could go through and check to make sure that worked out. But it should, since we've done everything correctly here. So I want you to pause the video at this point and try example 33. So for this example, if you went through and found AC, 8 times 3 is 24, and you need the middle term to add to be negative 14. Again, you didn't have to try too many here. Negative 1 and negative 24 is not going to work, but negative 2 and negative 12 will. So that's what you split your negative 14 into, and again, it doesn't matter which order. It's possible you put them in opposite order, and that's fine. The thing to be careful here, so the first two factor pretty easily. They have a 2m in common. You're left with a 4m minus 1. The thing to be careful with is the second set. In this case, you need to pull out a negative 3 again in order to get these signs to work out. If you only pull out a positive 3, you would have ended up with negative 4m plus 1, and that's not what you need as a common term. You need to pull out a negative 3 here, and then you would be left with a 4m and a minus 1, because 3 divided by negative 3 is negative 1. So then in common, they have a 4m minus 1, and the remaining terms are 2m minus 3. So this concludes the video on the AC method. You might want to go back and practice a few examples, either from the textbook or from the homework in this section, and then you can move on to the final method, which is the sum or difference of perfect cubes.